Hi, it's Akash with another video on physics. Today we'll be discussing kinematics and solving the students' doubt. And yes, it's a request, do subscribe to Genie the Akash videos. We will be providing better facilities once we get motivated by your subscriptions. Share and do ask your friends to subscribe. So the question is, a bullet with fixed initial velocity can enter two wooden blocks, each of width 0.05 meter. With the same initial velocity separately, if it can enter 0.2 meter in a wall. Distance it enter if a wooden board and wall are set together. We have to find this distance. So C is the first case. C is the first case where the bullet is introduced into the wooden block of thickness 0.05 meter each. So let us assume this distance, total distance covered for the bullet to come to a halt is equal to d1, right? And since these are the same wooden blocks, so throughout this journey it will have a deceleration of a, right? We assume it. We assume it is it will have a deceleration of a1, right? And it was initially thrown with the velocity v, constant velocity, okay? It is of an initial velocity of v. In the case 2 also, it will move up to a distance of d2, let us assume, and it will have a constant deceleration of a2 now, right? And its initial velocity will be v again. So it was given in the question, but we'll just assume their values. Now we see in the case of the question asked, where the distance is now of the initial part of in the wooden block will be d1 by 2, because it is only a single block, d1 by 2. We have to find the distance x, right? We have to find the distance x, and what is the value of this x? So, and the initial velocity of that will be again v. So we'll just write the equations to solve it. So what our equation says, we know initial velocity, or we'll write it like this: v final minus v initial, actually their squares, is equal to twice of acceleration into distance covered, right? This is the equation we will be using. So in the first case, the equation will appear something like this: v final we know is equal to 0, and v initial, this is the first case, v initial is equal to v, so it's v square is equal to 2as, right? So 2 into a1 into s is equal to d1, right? Is it clear to you? Yes, it is clear. So see, actually it will be in negative direction. Actually a1 is in negative direction, so it will be minus. It will be minus here. So is it clear? So we can we have reached to a place like v square is actually is equal to 2a into 2a1 into d1. From the second instance, we can write a similar equation. So we'll write for the second case 0 minus v square equal to 2a2 into d2, right? And we'll write it like this, that v square, there will be minus because it is a deceleration, so there will be minus. So is equal to v square equal to a2 d2. Up to this is clear to us. Now we'll implement what we have learned in this situation. See here, let us assume at this point the bullet will be having a velocity. At this point, the bullet will be having a velocity of vx. So for only this portion of the motion, it will have the equation will be like vx square minus v square is equal to twice of c. Since it is a wooden block, and we have known this, it will be decided by an amount of a1, and this wall will be decided by an amount of a2. It is constant property of them. So it will have 2a1, and this amount, let us assume it to be an the amount, not assume, but it is the amount is d1 by 2. So it will write d1 by 2. We will write d1 by 2. So this is the equation. So and see that we have just now written that 2a1 d1 is equal to v square. So we'll definitely write it 2a1 d1 is equal to v square. So implies vx square minus, there will be negative because of the acceleration is negative. It's a deceleration. So v square is equal to minus, this term is v square divided by 2, right? So divided by 2. We have written it. So we can easily see the value of vx square is actually equal to v square by 2, right? So we have reached this term. Now see here, the initial velocity is vx square by 2, and it reaches to a distance x and comes to a velocity of 0, right? So the equation at this point is will be final velocity is 0 is equal 0 minus vx square is equal to twice into deceleration, there is a negative term, twice a2 into x, and we need to find this x. So we know the value of vx is equal to v square by 2, and this negative to cancel out. So we assume this negative, both the negatives cancel out. So v square by 2 is equal to 2a2 into x, and the value of the x can be easily appreciated because we know v2 is equal to 2a2 d2. v2 is equal to 2a2 d2. So we'll write it like this: 2a2 d2 divided by 2 is equal to 2a2 into x. So value of x is nothing but d2 by 2. And yes, we have reached this value, and we know d2 has a value of 0.2 by 2 meter, is equal to 0.1 meter. So now we'll use a trick. What is the trick? See, since it is a wooden block, these two are wooden blocks, so the character of the bullet throughout its motion throughout these blocks will be similar as the block in this part, right? Again, the movement of the bullet through this wall will be constant for this wall. Now if we assume at this point the bullet will change its velocity, it will change its velocity but move in distance of d1 by 2, right? So it have completed half of its motion while moving through this, and rest half is given to this part. Similarly, in this wall, it will give its half motion to this half part and half motion to its next part. So we can find that this part is equivalent to, or rather we draw with the red pen, this part is equivalent to this part of the motion, right? And this part of the motion is equivalent to this part of the wall, right? So once we replace this red portion with this part, so it is very obviously clear to us that the wall will be impinged only by an amount of d2 by 2. This is the remaining part left, so answer is also d2 by 2. So we can use our normal trick to solve it also. And again, like, share and subscribe. Help this channel to grow, and keep watching GNEET the Akash videos.